Hello, hello everyone. Saurabh this side, and we will start this assignment question with the ninth module. So let's see the question here. So the question is regression modeling. So there are two questions. First is demonstrate estimation model evaluation using Python, and the second one is demonstrate stepwise regression. So before moving ahead, let's see what regression actually means. So regression is a statistical technique which is used to model the relationship between a dependent variable and one or more independent variables. That means it allows us to understand the effect of changes in the independent variable on the dependent variable, and with that we have to make prediction based on the observed data changes. There are several types of regression models, for example, logistic regression, multiple linear regression, etc. Now, for our topic, we have estimation model evaluation. So, let's see what it is. So, one common method for evaluating estimation model is to calculate the root mean square error, that is RMSE, which is the average difference between the predicted value and the actual value. Another method is to calculate R squared, which represents the proportion of total variation in the response variable that is explained by the predictor variables. Let's see this with an example. So here you can see this is an example where we have imported the NumPy, Matplotlib, and Skylern from the modules, and here we are using this mean squared errors, and we are printing R squared. So let's test it. So when we run it, then we can see that here precision, recall, F1 square, and support accuracy, everything is given in the tabular form. Now let's get into the second question, that is demonstrate the stepwise regression. So stepwise regression is a method used to automatically select a subset of predictor variable that is significantly contribute to the prediction of response variable, and the process involves adding or removing the predictor based on certain criteria. So this figure has been came out for the first uh, evaluation model. So this is the table 2 for this regression model, where this x is the dependent and y is the independent is x and y is the dependent. You can see that true values are these dots and predicted values are something which are close to these true values. That is the graph for the first one, and now we can see here its example. So let's clear the terminal first. We will see a figure 2. Here also we have imported the NumPy, Pandas library and stats models, and to generate sample data we have created some. Here you can see that OLS regression results have been given to us in the form of these tables, and we can also see here some another tables with some informations like intercept, x1 and r squared, etc. And we will also get a figure or graph for this too. It's taking some time, so let's wait for that. Here Here the note is also given that standard errors assume that the covariances matrix of the errors is correctly specified. That is the note that is been provided to. Now The graph is taking a lot of time, so let's jump into the next question or the next module, that is dimension reduction and dimension reduction, that is the same thing only. So here two questions are there: demonstrate how you will identify multicollinearity and how you will be applying the principal component analysis. So here first, so here you can see that dimensions reductions. So what is a dimension reduction? We have to first know what is a dimension reduction. So the next topic is dimensions reduction. So what is a dimension reduction? It is another technique used in statistical modeling to simplify complex data set by reducing the number of predictor values. So here this helps in eliminating the collinearity and improve the model interpretability, and principal component analysis is a commonly used method for dimension reduction in regression analysis. So the first one is dimension reductions and identifying the multicollinearity. So it demonstrates the process of identifying and addressing the multicollinearity in Python. So the identification is done like multicollinearity is a statistical phenomena in which two or more predictor variables in a multiple regression model are highly correlated, and this correlation can lead to issues in the estimation of regression coefficients, resulting in less reliable and interpretable results. Let's see it with an example. Here we have been using pandas library, numpy stats model, and seaborn. And if we want to run this, let's see what happens. So here seaborn is not imported, so let's install it. Install. Let's see this with an example. So here is an example of code. Here we have used pandas library, numpy stats model, and seaborn as well. So if we are going to run, then following output will be appearing. Here a tabular form is given where a pairs of highly correlated features are also given, like sepal length and petal length, sepal length, petal length, and petal width. So this is a form of the multicollinearity. Now coming towards the second one, that is principal component analysis, that is PCA using Python. So here dimensionality reduction and variance capture are the two topics where we have to transform, where the PCA has been implemented to transform correlation variables into a new set of uncorrelated variables. And in variance capture, we will understand how principal components capture maximum variance from the original data. So let's see it with an example too. The 10.2 has been, first we will clear it out. We have used here matplotlib, numpy, pandas 2, and when we run this, then there will be a graph showing the PCA. So the first principal component and second principal component graph has been plotted, and that we can see here too. Now coming towards our 10th 11th module, that is logistic regression modeling. So here two questions are there: how to perform logistic regression and how to perform Poisson regression using Python. First, let us know what is logical regression modeling techniques. So logistic regression is procedure to perform logistic regression. Now how to perform logistic regression using Python. Binary outcome modeling and application scenarios. Here we will learn the statistical method for modeling the probability of binary outcome, and in application scenarios we will explore where the logistic regression is widely used within various fields. Now, for example, here the 11th, let's test that too. Yeah, so here we can clearly see the graph has been shown out. So this is what the logistic regression meant. Here you can clearly see train a logistical regression classifier. Now, coming to the second one, how to perform Poisson regression using Python. So there are two methods: count data analysis, Poisson distribution. So the understand how Poisson regression is utilized for count data analysis, and in Poisson distribution, learn about the suitability of Poisson regression from data following a Poisson distribution. So let's see it with an example of code 2. Here we have also used the stats mod and numpy as our packages. And let's clear it out first. Here we can clearly see the output, that is the generalized linear model regression result, where it is given all the details about this, and constant and x errors are also given, standard errors, and x1 and x2 are the variables, and these errors and z has also been provided. Now moving towards the next question, that is association rules. So how to mine association rules, how to apply confidence difference criteria, and how to apply confidence quotient criteria. So we will see them one by one. So the first one is, let's start with basic. What is association rule mining in Python? So it is the technique for discovering interesting relationship in large data sets. And the confidence criteria is applying confidence difference criteria and confidence quotient in association rule. We will learn them shortly. Now, the first question that has arrived was how to mine association rule using Python. So let's see it. Mining association rule is a data mining technique used to discover interesting relationships, patterns, or association within large dataset. It is a commonly applied to transactional database such as retail shop. For example, when we are going to a shop, we are buying something like bread, butter, etc. So we will find out the transactions and we will build some relation whether one item is forcing a customer to buy another item. And in this way, we will find out the relationship between these different item set, whether they are buy together or not. And in this way, we can find out that. So let's see with an example too. So 12.1. Let's clear it out. Now let's see it with an example. So here we have imported the pandas library as well as the ML extend and pre-processing and frequent patterns for a priori and association rules. So here we have also given the transactions and data sets. Now let's start run the program and see the rules as we have wanted to print the rules. We can see here that these bread eggs, egg bread and their support, consequent support, confidence, lift, leverage, conviction has also been given. And from here we can all easily find out the rules that can be made out of them. So that's what it is. Now let's jump into the next question. Applying confidence criteria in association rule mining. So the confidence difference criteria. So it is filtering rules based on the magnitude of confidence difference. And confidence quotient is quantifying the level of confidence in rules or prediction. So let's say it with example 2. Let us clear the screen. When we run, we can find out the confidence differences. So here, as we have mentioned everything precisely, we have find out that confidence difference is zero point 0.0. Let's see the confidence quotient. Here we have find out that the confidence quotient is 1.5, confidence was 1, lift was 1.5 for bread, and for milk and saffron it was confidence 0.80, 1.2, and quotient was 0.960. So with the help of these programs, we has also understand about the confidence criteria in association rule mining, that are confidence difference criteria and confidence quotient criteria. Now after this video can be ended because we have solved all the assignment questions from 9 to 12th module, that is 9, 10, 11 and 12.